Welcome dear students. In previous lecture we have seen this analysis of beam subjected to sinking of support. Now in this lecture we will learn the analysis of beam subjected to initial rotation plus the sinking of support. Now suppose the support A having initial rotation in clockwise direction. Suppose it's 10 by EI, and the same sinking of support is B and C. In the previous lectures, that is lecture number 20, this support B sink by 300 by EI, and C sink by 100 by EI. So now the first step in this flexibility matrix is to find out the degree of indeterminacy. So here unknown forces are the 1, 2, 3, here is 4 and the 5. So di, that is unknown force, minus the available equation, that is the 3, sigma fx, sigma fy and the sigma m. So is 2. Is 2 indicates means we have to remove the 2 forces from these 5 unknown forces. So and make the structure the determinant structures. So we have decided to remove the moment at A and moment at B. So that is easy to analyze this beam. So remove the moments at A and B. It means this is our Q matrix. That is what you have removed the forces, that is our Q matrix. So now we draw here this diagram in this way. We have inserted a hinge here, inserted here hinge, now this is our beam. Now this structure is called as the release structure. 4 meter, 2 meter, and this is the 8 meter, A, B and C. What is, we have removed the 2 forces, that is moment at A and moment at B. So this structure is called as the release structures. Now apply the rotation where we release the forces. Now if you release the moment, apply the rotation. If you release the force, apply the force. So now here we apply the rotation in this way, and here we apply the rotation like this. So this is our coordinate number 1, this is our coordinate number 2. This is 8 meter, this is 6 meter. Now having the same I as we seen in the lecture number 20. Now our basic equation is dq is equal to dql plus f into q. These all are the matrix, dq matrix, then f matrix, then q matrix and dql matrix. Now dq is nothing but the initial rotation at the coordinate where we remove the forces. Now here we remove the moment at A and remove the moment at B. So we have to find out the initial displacement at A and at B. dql is the displacement caused at the coordinate at A and B due to this external loading. F is the flexibility matrix and Q is the unknown matrix. So now we develop the 1 by 1 matrix. So first we develop the flexible matrix F matrix, that is the F11, F21, F12 and F22. Your DI is 2, it means 2 by 2 matrix. So now this is the beam. Now this is our rotation. Apply rotation at the 1. So, and this is our coordinate number 2. So give this as 1, F1 and F2. Now we are applying the rotation at 1. So you use 1 and give this as the 1. Now due to this rotation, we have to find out the slope at the 1. Okay. And this will produce the rotation at 2 in this direction. Okay, so now what the rotation produced at 2 1 is the same as that of we have assumed here. So first we develop the F11. Now F11, that is the rotation at 1 due to the application of the rotation at 1. So that is LAB upon 3 EI. That is 8 by 3 EI. So this becomes 2.67 divided by EI. Now this F21 is also is equal to F12, means rotation developed at 2 due to the application of rotation at the 1. This is our, in that case, that is this rotation at 1 will not produce any rotation in the span BC, because here is a insert is a hinge, so this will not produce any rotation in the span BC. So that LAB divided by 6 EI. This will produce the here rotation, and that value is L upon 6 EI. And this direction is the same that we have the assume, that is why this value is the positive, and that is again the 8 by 6 EI. So that is equal to 1.33 EI. Now next we will develop apply the rotation at the coordinate 2. This is our again this is our beam A. This is B and C. So apply your rotation at 2. Okay, so this is produced like this. So this will produce rotation at 1 like this. So what assumed direction and this direction is the same, that is why this value is positive, and this and this. Now here is coordinate is 2, coordinate is 1, right? F and F1 and F2. Now we are applying here the rotation at 2, so this is 2 and the 2. This already we have calculated F12 and F21 is the same. So now remaining is the F22, and that is equal to this LAB divided by 3 EI plus LBC divided by 3 EI. So LAB is how much? Is 8 divided by 3 EI plus LBC is, this is 6 meter, it's 8 meter. So this becomes 6 upon 3 EI. So this total becomes 2.67 plus this 2. It becomes 4.67 EI. That already we have developed in the lecture number 20. Now this F matrix, that is 2.67, 1.33, 1.33 and 4.67. Okay. Now we develop the DQL matrix. So here we develop the DQL matrix. Now DQL matrix. So now we know this is our beam. Here inserted the hinge, here inserted the hinge. Now this is a load of 10 kilonewton per meter, and this is the 50 kilonewton. Now this is the deflected shape due to this the forces. So now we have to calculate the rotation developed at 1, that is the dQL, due to this external loading. So this rotation is in this direction, like this, is clockwise. And what we have assumed the direction rotation is the same, that is why this value is the positive. And for this the formula is the WL directly standard, WL cube upon 24 EI. So that is equal to W is the 10 into 8 cube divided by 24 EI. So that value is nothing but the 213.33 divided by EI. Now add coordinate 2. Now this is a 1, this is a 2. So now we have to calculate the displacement caused at 2 due to the external loading, that is the dQL2. So this is the rotation in the AB span also and the BC span also due to the external loading. So here the developed rotation in the AB span in this way and BC span in this way, and what we are assume rotation are the same, that is why dQL for this AB span and BC span is the positive. Now for this formula is the WL cube upon 24 EI, and for this point load the formula is W into B L square minus B square divided by 6 EI. Now if you put the value in this equation, the final value we write here the 2 divided by the EI. So we got here the dQL matrix is equal to here what 213.33 and 302.21 upon EI. So we got the dQL matrix also, then F matrix also, then we find here the Q matrix, that is the unknown matrix. What is here? We have removed the moment at A, so our coordinate number 1 is MA. Now we have removed this moment at B, so that given coordinate number 2, so that is MB. So this is the Q matrix, dQL matrix. Now remaining is the dQ matrix. Now here we know this delta A is 0. Now here this delta B that given is 300 by the EI, and delta C that given is the 100 divided by the EI. So now due to this sinking of the support B, here develop the movement like this, and this will the same direction develop movement at the here. These are the sinking moment. Here. Now just suppose this is our fixed beam. Now suppose this is a fixed beam, is sink by any delta, so this movement is produced like this and here at like this. In the same way this movement is here in the fashion and this in the same fashion here. So now these are the movements. Now at 1, so this we called as the dQ1, and at this 2 we called as this dQ2, that is the initial displacement due to this sinking and any rotation. So now here also rotation is here, initial rotation is given, so that if initial rotation is given like here in this way, and that is the 10 by E. So here initial rotation. So at this one, that is our dq1. So now here is dq1, that is the is slope developed at 1 due to the sinking of support. Now this is now IB, slope at this is how much is 300. The slope is equal to what is the delta by L. So here is delta 2 minus this delta 1, that is delta B minus delta A, so that is equal to is a delta by L. So we can write this delta as delta B minus delta A, so that is 300 minus 0, okay, so that's 300 divided by 8 EI. This is the IB. Now here IB for this BC span, this is now 100 upon the EI. So this IB is nothing but the is delta by L, but here delta is equal to delta B minus delta C. So here 200 is 300 minus 200 divided by the 6 EI. So this becomes is 100 EI. This becomes 200 divided by 6 EI. So IB for BC span is 200 upon 6 EI, and IB in the AB span is equal to 300 divided by 8 EI. Now same is the here, this IB is nothing but the 300 divided by 8 EI. Now this is the dq1 is the slope developed at 1 due to the sinking of support at this 2 here. So this is in the developed slope is in anti-clockwise fashion, because what we have assumed rotation in this clockwise direction, but developed slope in the anti-clockwise fashion, that is y is minus 300 divided by 8 EI for here. And here initial rotation is a clockwise direction. What? This is also clockwise and this also the clockwise, so that is why that value is the positive, and it is the 10 upon EI. So this becomes is minus 27.5 divided by EI. Now dq2, that is equal to is slope developed at 2 due to the sinking. So slope at B in AB span plus slope at B in this BC span. So develop the slope and what we are assumed directions, both are the same. This is the assumed direction and the developed direction, both are the same. That is why here both is the plus. So slope at B in AB is 300 divided by 8 EI, and here is a plus 200 divided by 6 EI, because this direction, what you assume direction, rotation is the same. That is why is a positive, and total is the 70.83 divided by the EI. So now this dq matrix, we can say that is minus 27.5 and 70.83 1 upon 8. So now we got all this matrix, dq matrix, dql matrix, f matrix and the q matrix. Now we'll put all this value. So our formula is the dq is equal to dql matrix plus f into q matrix. So DQ is the minus 27.5 and 70.83. 1 upon EI is equal to, now here is DQL matrix that already is a 213.33 and 302.21. 1 upon EI, then plus F matrix 2.67, 1.33, 1.33 and 4.67. 1 upon EI, and what is there? MA and MB. So if you solve this matrix, that MA and MB, that if you, so that final value is the minus 76.34 and minus 27.80. Now this value are the minus. That means what? Our assumed direction are the sagging. This is sagging also, this is the sagging also, but this value are the minus. It means these are the hogging moments. So now we plot here the bend moment diagram. This is for the AB span, WL square by 8, and here this is 80, and this is 66.67. This minus 76 means hogging here, is 27 means here, and here at simply supported the bend moment is 0. So join this all points, 27.8, and here 76.34 minus, this is plus, minus and plus, and this is the B. Thank you.